Hi everyone, this video will walk you through the tokenomics design for Bitcoin-IPC and then show you a live demo of actually meeting rewards. The core principle behind Bitcoin-IPC's incentive design is simple but powerful. Staking in a Bitcoin-IPC subnet is to Bitcoin-IPC what proof-of-work mining is to Bitcoin itself. Just like miners secure Bitcoin by committing real-world resources, energy and hardware, stakers in Bitcoin-IPC commit real economic value by locking up native L1 Bitcoin. We call the reward token IPC-BTC. Validators obtain it regardless of which Bitcoin-IPC subnet their stake is on. Now, here's something that makes Bitcoin-IPC unique. We're not only rewarding validators, we're also rewarding users who send cross-subnet transfers, that is, transfers across different Bitcoin-IPC subnets. The goal is simple: encourage real adoption, reward real usage. The split could be, for example, 70% of rewards going to validators and 30% going to users sending cross-subnet transfers. This ratio is an example value. We'll be locking these numbers down in the future, ideally through community discussions. Now let's talk about the token itself. IPC-BTC has a hard-capped deflationary supply. This could be, for example, 42 million tokens total. Here's how that looks concretely, and keep in mind, the specific numbers here are examples. We'll be finalizing them going forward, ideally through open community discussions. We deliberately mirror Bitcoin's emission schedule, including halving periods. Let's assume Bitcoin-IPC launches at Bitcoin block 1 million. From that point, the reward emission runs in epochs of duration roughly 4 years each, just like Bitcoin. And this corresponds to roughly 210,000 Bitcoin blocks. In the first epoch, as we can see on the bar chart, 21 million IPC-BTC get minted. That's 50% of the total supply. In the second epoch, that drops to 10.5 million, 25% of the supply. And so on, halving each epoch, converging toward the 42 million cap. Let's now look within each epoch, where we divide time into snapshots. Every epoch is split into a number of smaller snapshots, each snapshot being 1,000 Bitcoin blocks long, corresponding to a time period of approximately 1 week. With our numbers so far, this implies 210 snapshots per epoch. At every snapshot, a fixed allocation of IPC-BTC is distributed, and validators must be staking throughout the entire snapshot period to qualify. With our numbers, that works out to 100,000 IPC-BTC per snapshot in the first epoch. Of that, 70,000 IPC-BTC go to validators, 30,000 IPC-BTC go to users who send cross-subnet transfers, and all proportional to the total contributions throughout the snapshot. This creates a mechanism very similar to Bitcoin's difficulty adjustment. It's automatic, objective, and anchored to the Bitcoin chain itself. And here's the beautiful part. All of this information lives on Bitcoin mainnet. Who stakes how much collateral in which Bitcoin-IPC subnet? It's all there. The amounts of cross-chain transactions also there. Fully transparent, fully public, no trust required. Rewards in Bitcoin-IPC are minted on a dedicated chain called the Emission chain. This is a special purpose Bitcoin-IPC subnet whose entire job is to monitor the Bitcoin chain and mint IPC-BTC rewards to the validators and users, according exactly to the rules that we described. Right now, the validators of the Emission chain are doing this monitoring. In the future, we're planning to fully decentralize this role and make it completely trustless. And we can do that precisely because the ground truth is publicly available on Bitcoin. Everything is verifiable, everything is open, and that's the whole point. And one more thing, and this matters a lot to us, we want this to be a fair launch. No pre-allocated team tokens, no investor allocation, no insiders getting a head start. If you believe in Bitcoin-IPC, you stake L1 Bitcoin and you earn IPC-BTC alongside everyone else. That's it. This is a deliberate choice to align Bitcoin-IPC with Bitcoin's own ethos. We want something that earns credibility from day one. Now let's see this live, but one quick thing before we start. To make things easier to follow, we're going to use simplified example values in the demo. Specifically, snapshots will be 10 Bitcoin blocks long and 1,000 IPC-BTC tokens will be minted per snapshot. And for simplicity, in the demo we are going to focus on staking rewards only. Cross-subnet transfers work the same way, but we leave them for another time. And again, these numbers are purely for illustration. The actual values will be finalized in the future. With that said, here we go. What we're looking at is logs from a test deployment of the Emission chain. On the left, we can see the height of the emission chain. Next to it, we can see the height of Bitcoin. We're using a local distance for this demo. And in the middle, we can see the emission chain creating logs as it is processing Bitcoin blocks and extracting Bitcoin-IPC related transactions from them, such as who has staked, how much, and what cross-net transfers have gone through, and then updating the IPC-BTC rewards accordingly. Let's look at some actual balances from the emission chain through MetaMask, who has been connected to the emission chain. Here is a validator who is already participating in some Bitcoin-IPC subnets. As a reminder, by default, there are 2 tokens in every Bitcoin-IPC subnet. The first is a wrapped representation of BTC. Any user or validator can deposit BTC from the Bitcoin chain and obtain wrapped BTC in the subnet. In this case, it happens that this validator has already deposited 2.4 BTC in this subnet. The second is the reward token, IPC-BTC, which, as we explained, is minted on the emission chain, but it exists on any other Bitcoin-IPC subnet by default. And indeed, our protocol will natively allow users to transfer their IPC-BTC tokens among different subnets. Now let's look at 2 new validators, the ones that I call validator 5 and validator 6. Since they are not yet participating in any Bitcoin-IPC subnet, they haven't received any IPC-BTC on the emission chain. Let's go ahead and have these 2 validators join a Bitcoin-IPC subnet. We can use these 2 dedicated commands. The first is saying that this validator with these others, which by the way is the one that we have connected here on MetaMask, wants to join an existing subnet. And what is important to mention here is that it is taking 2 Bitcoin as collateral. The validator 6 will be joining the same subnet and it will be staking 4 Bitcoin as collateral. I want to submit these transactions at the same time so that both validators join the protocol at the same snapshot, because then it will be easier to compare the amounts that we see on MetaMask regarding the rewards they will receive. I can go ahead now and submit the 2 commands. We can see that they have both joined at height 152. Now we need to wait until the subnet creates a checkpoint. This is a subnet configurable parameter. In this case, it's set to 60 blocks. And whenever the subnet creates a checkpoint, the balances, the actual validator set changes. So these 2 validators will actually start participating in the subnet whenever it creates a checkpoint. Let's pause this demo and then we will fast forward when that happens. We are back, and at this point, not only has the subnet created a checkpoint, but also snapshot 16 has been finished, as we can see from the logs here. Snapshot 16 was the first one in which both validator 5 and validator 6 were staking for its whole duration. The emission chain offers a way to directly query it for the rewards that it has allocated, and it is through this command here. What we can see is that for snapshot 16, these validators have been actively staking. Our validators are this is validator 5, and this is validator 6. As we can see, it has detected that validator 6 was staking double the collateral, and the award that are minted to each of them is proportional to this. Specifically, validator 5 will get this amount over the total awarded collateral. Validator 6 will get its staked amount over the total awarded collateral. And if we switch to MetaMask, we see that the balance of validator 5 is now 161 IPC-BTC, and the balance of validator 6 is the double amount, 322 IPC-BTC. To recap, in this video we talked about the tokenomics of Bitcoin-IPC. It has a deflationary, halving-based emission schedule, it's anchored to L1 Bitcoin staking, it is rewarding both validators and real network usage, and it has a fair launch. The crown truth lives on Bitcoin. The incentives are aligned with Bitcoin, and the system earns its credibility the same way as Bitcoin does, through transparency and commitment. If you want to dig deeper, get involved in the community discussion around finalizing these parameters. Your input matters. Thanks for watching.